Welcome to our session on accelerating your next scalable high-performance digital cockpit. My name is Åsa Forsell, and I am a Senior Automotive Product Manager here at the Qt company. For those of you who are not familiar with Qt, Qt is a cross-platform HMI framework with an active community of over 1.5 million developers and over 1 billion devices deployed across the globe. Today's session will consist of 3 different parts. I will start the session covering automotive HMI trends and the future of digital cockpit. This includes going over some of the trends we as a UI framework provider see in the markets and the challenges many OEMs are facing in the midst of the software revolution that is happening in the automotive industry. After this, my colleague Marek Mahacek will talk about why smarter products need smarter development flows and will give some concrete examples on how to achieve a consistent look and feel across your complete product family, with the help of cross-platform tools that are built to meet the needs of the future. After Marek's session, we will have time for a live Q&A, where we'll be really happy to answer any questions that might come up during the talk. Thank you a lot for joining, and let's get started. So we at the Qt company are very lucky to work with some of the biggest names in the industry, including brands like Hyundai, Kia, Mercedes, and countless other automotive manufacturers. Through this, we have a unique vantage point into what are the automotive HMI trends and what does the future of the digital cockpit look like, whether we're talking about traditional OEMs or some of the up-and-coming electric vehicle manufacturers. In this session, I plan to concentrate on the software trends specifically and what challenges these manufacturers are facing as the industry and consumer expectations are rapidly changing. So when we look at new vehicle releases, it is obvious that the screens are getting larger and that there are significantly more of them. On top of the traditional cluster and infotainment screens, additional domains like HVAC, passenger, and rear seat entertainment screens are becoming more commonplace. In addition, screens are in some cases replacing traditional mirrors with their advanced augmented reality visualizations to further make driving more safe and more convenient. With the emergence and normalization of semi-autonomous and autonomous features, it is more important than ever before to be able to visualize information of the vehicle's intentions and surroundings to the driver in a clear and concise manner. It is also more important than ever before to make sure that the different domains of the vehicle have seamless communication and information sharing for a great user experience. In the context of the digital cockpit, these separate screens should function as one coherent system, no matter how many SoCs, operating systems, and processes are running under the hood. So, looking at this, it's quite safe to say that the future of automotive is in software. When we look at the market forecast, software and electronic components market is expected to vastly outpace growth in the overall automotive market. This means that going forward, more and more of the automotive revenue will be revolving around software. It is also clear that software is becoming a bigger differentiator than some other hardware components of the vehicle, as majority of new innovation and features happen on the software side. And these innovations include things like advanced driver assistance systems, autonomous and semi-autonomous driving, performance optimizations for electric vehicles, safety systems like collision prevention and driver tiredness detection, and so forth. And this in turn puts software at the center of OEMs' future strategies, making software and SoC selection processes more important than ever before. And one of the biggest drivers for this is consumer expectations. The consumers expect their cars to be an extension of their digital lives. They are used to receiving constant updates that improve their device functionality, introduces new features, and provides security updates to keep them safe. We are used to quickly searching through app stores for apps that immediately solve a problem for us, and we have a myriad of apps that we use on a daily basis. Therefore, it's only natural to expect to have these services, whether we're talking about Spotify, calendar, WhatsApp, or digital assistants, to be available in our car as well. And especially in the wake of industry pioneers like Tesla and NIO, consumers expect the same from cars already today. The vehicle life cycle needs to be extended through software. The expectations of being able to customize the user experience, purchase new features through app stores, and receive regular updates is forcing automakers to change their software strategies going forward. In fact, a huge part of Tesla's early success can be attributed to the exceptional user experience they have managed to build around software. When we look at the consumer expectations of constantly getting new content and updates, it also means that the software-defined vehicle never stops evolving. This in turn requires a lot of flexibility in the software platform. And then again, this puts a lot of new requirements on the OEMs themselves. They need to have continuous development and deployment setups to push new updates out more frequently. They need to be able to test their updates and get user insights through data analytics in order to provide better user experiences. And at the same time, just being able to update applications over the air is not enough. They also need to be able to update the firmware as well to ensure future scalability. And all of this is not just for vanity. Safety updates and new features need to be introduced as well, sometimes even years after the car has rolled out of the factory. And overall, the whole software stack needs to be cross-platform so that the OEMs can more easily adapt to situations like the chip shortage that we are seeing right now. A real-life example of this is Tesla. Elon Musk mentioned in their July earnings call when discussing the chip shortage issue that they were able to substitute alternative chips and then write the firmware in a matter of weeks. And that it's not just a matter of swapping out a chip, you also have to rewrite the software. And again, this has made them less susceptible to production outage due to the chip shortage. But let's face it, quick turnarounds like this are only possible if your software architecture is already rather lean and intended to be cross-platform from the beginning. So let's look at some other industry examples of flexible software and update capabilities. The first example is Lucid Motors, a US-based EV company that released their Dream Drive concept for their Lucid Air vehicle earlier this month. One of the key aspects of the Dream Drive was their Ethernet ring concept, where 4 gateways are connected at each corner of the car, providing in-car communication at gigabit speed. This in-car communication setup is integral for readying the Lucid Air for more advanced driving features in the future without the need for any hardware updates. In fact, the software aspect is in a huge role in their consumer-facing marketing campaigns, intending to differentiate them from traditional OEMs with this advanced software thinking. A second example I have is Hyundai Motors luxury brand Genesis and their new electric SUV GV60. In their previous iterations, they've already been able to provide some level of software updates over the air, But in this new iteration of their platform, they are able to provide over-the-air updates to everything from EV integrated control devices to suspension, brakes, steering wheel, air pads, and ADAS systems. So it's clear that the trend is going forward to more modularity and more updatability so that the software can live and breathe with the car. Indeed, great software has become a competitive advantage for OEMs, and for those that are behind the curve, bad software has become a burden they need to overcome. Looking into this, I found some interesting numbers on how many and how frequent update Chinese OEM NIO has been rolling out between October 2018 and October 2020. And these numbers included 29 major iterations covering 4 different vehicle models, 131 new features, 280 feature optimizations, and 411 total product improvements, and over 350,000 pushes. Looking at these numbers, it's quite safe to say that NIO vehicles purchased in 2018 provide a very different user experience now than they did then, thanks to evolving software. Due to these frequent updates, cars are no longer one-off purchases. Instead, their life cycle continues for years after coming out of the factory. With frequent update cycles, OEMs can validate new features with live test audiences, optimize user experience based on real usage data, and provide quick bug fixes if any issues are found, potentially eliminating the need for extremely expensive recalls. There are also new monetization opportunities from upselling features and services, which in turn allows OEMs to increase the overall lifetime value of a vehicle and increase the revenues coming from said car. We've now gone over some of the great success stories, but the reality is that many still struggle to keep up. These trends are causing a lot of turmoil in the industry because switching from a hardware manufacturer to a software company is no easy feat to achieve. Often large organizational changes are a requirement, and there's a lot of politics around this. Also, there needs to be a mindset change from providing one-off products to providing software services that continue evolving over time. Many OEMs also do not have much experience in software, as they have previously outsourced a lot of the software work to suppliers, using plethora of tools that don't necessarily talk to each other. Right now, we're seeing that some OEMs are looking to move a lot of the software development in-house, while some want to outsource even more of it to the suppliers. So there's a lot of interesting changes happening in the industry right now. And the reality is that current automotive software stack is way too complex. Often it consists of monolith code bases, a patchwork of applications that do not talk to each other, domains created by different suppliers with different tool chains at different times. And there's often dependencies on archaic systems that are extremely hard to update and work on. So to move forward, the current software architecture needs to evolve. And McKinsey highlights this automotive software architecture evolution rather well in their Mapping the Automotive Software and Electronic Landscape through 2030 analysis. I've added a link to it on the screen in case you're interested in digging deeper into it. So feel free to take a screenshot of this and then go through the link and read the whole report for yourself. It's rather interesting. But when we look at the beginning of this graph, the first evolution of the software architecture in vehicles consisted of independent ECUs with isolated functions with a separate ECU for each of these functions. In the second stages, we started seeing collaboration of ECUs within one domain, but very limited communication between the domains themselves. And then in the third stage, which is where most of the OEMs currently stand, there's a little bit better collaboration via a central gateway, some cross-functional connections, and the ability to handle complex functions like adaptive cruise control and so forth. Looking at the future, in stage 4, the domain centralized stage, there will be a central domain controller that is able to consolidate functions and communicate easily between them. This setup allows handling of much more complex use cases than before. The analysis expects that by 2030, most OEMs will have reached stage 5, which is vehicle centralized architecture, where you would be having a virtual domain with limited dedicated hardware and an Ethernet backbone, like we saw in the Lucid Air example earlier in this presentation. This setup would allow for complex functions and high performance computing that will be the requirement for truly autonomous driving experience. Looking at these trends and analysis, cross-platform thinking is vital going forward. The software cannot be too dependent on the hardware environment to avoid production outages like we are now seeing due to the chip shortage. And at the same time, we need to be able to support more screens that will still need to be seamlessly connected to each other. Connectivity is the key, no matter what the operating system or the underlying hardware platform. The trend in hardware is also moving towards multi-core SoCs with multiple application processors, MCUs, and GPUs to support all of the required functions within that digital cockpit. To build a cohesive system, the software needs to be able to run on all of these to support the multitude of use cases in a digital cockpit. Therefore, it is important that the tools used also scale to match these requirements. Here you can see a simple illustration of an example digital cockpit. In this scenario, we have multiple screens running various applications on a plethora of different operating systems. Sometimes there also might be multiple SoCs at play depending on the requirements and the preferences of the manufacturer. This setup might have Linux-based cluster and head-up display with real-time operating system like QNX or Integrity running the safety-critical parts. The IVI is often separate from the cluster, running on a different operating system and sometimes even different SoC. The OS might be Android Automotive OS, Linux, or perhaps QNX even. The passenger display and possible rear seat entertainment might mirror the IVI, or they might be completely separate. Many OEMs also want to include companion applications into the mix, which then will run on either Android or iOS. And while the digital cockpit consists of multiple different screens, operating systems, processes, SoCs, and applications, the final result still has to appear seamless to the end user. The end user shouldn't have to be aware of the fact that the cluster and the IVI are different systems, because for them, they are all core part of the overall vehicle driving experience. Therefore, it is a huge benefit and of huge value if the OEM is able to use the same UI framework to cover all of these different use cases and eliminate the complexity and reuse as many UI components as possible and as much of the code as possible. So let's take a look at a concrete example of a system where we have multiple screens, multiple operating systems, and multiple cores in use, all the while providing a smooth and cohesive user experience to the driver. So when we look at the yellow box within the cluster, we have a 3D scene built with Qt running on Linux operating system. In the red box, we see some safety critical icons running on QNX using the Qt Safe renderer. The purple boxes that you can see both on the cluster and on the head-up display are running or are built with Qt for MCUs, and they are running on the SoC's microcontroller unit without any operating system. And while there is a lot of complexity in the systems involved, the end result is seamless, and the end user wouldn't know what is happening on the backend. Due to Qt's versatility and cross-platform nature, the design and the development workflow for a setup like this is also simple and easy to use both for the designers and for the developers. But now it's time for me to say thank you for your time and give floor to my colleague Marek Mahacek. I've been covering some of the higher level trends, but Marek will tell you why smarter products need smarter development and give some concrete examples on how to achieve a consistent look and feel across your complete product family with the help of cross-platform tools that are built to meet the needs of the future.
Hi everybody. My today's presentation is about a modern approach for the HMI development to achieve a consistent look and feel across your complete product line. My name is Marek Mahacek. I'm working at the Qt company in business development for the MCU product line for whole EMEA. I started my career in the embedded development for digital video products in the industrial and consumer device area. I joined the Qt company to oversee and grow the Qt MCU offering, and we are developing product strategies with existing and new customers in exciting areas: automotive, mobility, e-bikes, white goods, industrial applications. That is really exciting. Now, I would like to talk about today about the approach that we need in smarter development, because the products get smarter every day. How do we achieve a consistent look and feel and a scalable business here? And I will give some examples and use cases and also show some latest UX trends. Let's start with a short introduction. We are a company with 450 employees and grew very fast in the last years. And we have a revenue of roughly 80 million by end of 2020 and count several thousand customers which we work with. Now, we offer a complete framework. That is our core business. And it consists of the design part, of course. We offer the Qt Design Studio, but you are able to use any other third-party tool like Figma or Adobe. Once you got used to it, you may prefer those. And we, of course, have import tools so that there is a seamless integration into this. There are three main tracks in the development area, depending on what platform you choose. So it's between desktop, microprocessor devices, and in the end, microcontrollers. We cover all those. And in the end, you have some testing, quality assurance. You may need some third-party tools which are integrated into the platform. And we should not forget the download and production process, which belongs to nowadays into a complete product offering. People expect updates, and the deployment needs to be seamless and repeatable. So all these things belong to the framework, but that's of course just a part of the whole picture. So if we look at the complete ecosystem, we have to take languages and operating system into account. With C++ and QML, you would cover most of those things, but of course, in nowadays ecosystem, we have to integrate Python, JavaScript, HTML, support different operating systems down to very specific ones like Unix or AUTOSAR for the automotive area, or FreeRTOS or other RTOSes in the microcontroller domain. Looking at the development tools, we have several aspects and tools which we offer here. It's not only the Qt Creator, but tools for safety, specific things in the packages for automotive, other tools in embedded software and so on. So this is a big part in the organization. And of course, we shouldn't forget the designers. They make the thing look great. They make the wireframes, they make the logic for the interaction, and so on. So this would be the complete picture, and this is all you need if you want to make an application. Now let's go into more theory, and we commissioned a survey which was compiled by Forrester Consulting in May 2021. And we just asked ourselves, how can we increase the innovation and drive growth by modernizing the digital product delivery? And we surveyed 262 decision makers from global enterprises, and they all were related to embedded devices and connected product development. And simple outcome here, they were all the same, most of them had the same opinion. The product has to be digital for the future, and it has to be connected. And also, not a big surprise, the customer needs to be at the center. So if we look into more depth, we see that the organizational and cultural changes often hinder development. So there's sometimes lack of collaboration. There are sometimes not the same objectives, slow processes, difficulty in scaling, and most of our companies we work with, they have a developer shortage typically, because you have need specialized personnel, and that's not that easy today. 80% say that these things hinder their product delivery, and 30% they observe delays of 7 to 12 months, and a delay of 1 year to launch a product is quite costly. Now, this probably leads us to the conclusion that the traditional development practices may be insufficient in some points. And if we look at the shift to smartphone-like UX, because everybody is used to smartphone-like UXs, and is used to continual innovation and dynamic software development lifecycle, we need to also do this shift to those requirements. So the customer expectation here, that it has to be easy to use, similar to a cell phone, and needs to be continuously improved. And if it's connected, then it also needs to be protected. These are requirements which are key for today's products. Now, as a summary, 70% call out that customer experience is their #1 measure for success. And again, it's the intuitivity and consistency of an UX. The product needs to work as expected and keep working. So updates need to be very, very thoroughly provided, and it has to be easy to maintain. Otherwise, it will eat off your margin. So if we now take a step back and look what we said before, so what is our development environment? So we have to design things, we have to develop things, and we have to test things. And we probably agree, all of us, that we want to work collaborative and agile as a modern nowadays process. Now, this sounds pretty trivial, and if we just answer that we have a Qt Design Studio for that, and we have Creator IDE, and you have Squish and Cocoa for testing, I think it's a too short step, because this doesn't sound really that it's customer centric. You as our customer, you are not in the focus of this. We just offer you products, right? So I think we need a different approach. So if you look from the customer perspective, and that's you as a development company, as a tier 1, as an automotive customer, then probably we want together enhance the user experience. That's valuable for you. We want to decrease the efforts in product development, and we want to deliver scalability so that you can fulfill the requirements for a worldwide business. And then, of course, support and maintenance is a cost factor and a total quality assurance matter. So everybody will agree that this is important. And in the end, also, there's always some risks, and we know that we have resource gaps. So this is also something we think is an important piece of the total value our framework has to deliver. Now, how can we deliver such a value to you? We need to think about each of those points. Can we improve it? The user experience, we said, is graphics, but of course also the behavior like speed and responsiveness. To decrease efforts in development requires reusability of code, collaborative development, and in the end also multi-platform deployment. Why that is, I will talk about later. For the scalability for a worldwide offering, of course, localization, internationalization is a key. Safety and legal requirements and standards need to be fulfilled. And of course, there's local content and regional data to be taken into account. So all this is needed. For the optimizing of the support and maintenance area, that is something which nowadays is a must-have. So over-the-air updates, feature updates is a key, and to keep the total quality in that complex environment is a challenge for every one of us. I want to mention that we are really happy to have an open source tool chain as well, and the great developer community. This really helps us to evolve and develop our products and offering further. We get a lot of feedback here, and not to forget our professional services. Let's start with the platforms. So the platform impact UI design. In this open example, we have chosen just a mid-range, low and high-end UI. But the high-end, of course, probably comes with a companion app where you have to sign in, and which gives you some other advantages. And such different platforms, they can limit your user performance, of course. They may force teams to adapt UI designs with their unique tooling they have. And also you have, from the history, maybe traditional methods, how manual coding and creation assets, and you have to recreate them more often as you go along with new product developments. Now, in total, this may result in inconsistency or poorly performing UIs, or even in a bad customer experience. So what we see here is that we need a cross-platform and a collaborative development approach. And looking at the different product categories, which is just named a few here, from home appliances over mobile wearables and automotive, as you have seen in Asa's presentation, have completely different requirements, therefore need different platforms, and also, of course, different UIs. So how do we achieve that we can be still collaborative and make and reuse our code? So we have put everything in one system. So our tool chain works for all 4 of those domains. You can prototype everything on your desktop and then compile down to a MCU, an MPU, or a hybrid multi-core in automotive. That's quite the complex part, of course, because you may end up running 2 or 3 different operating systems. But the more important it is that you can use the same visuals, the same graphics over for all those products. Now, whether you start with a low-end product where you have to look at the small footprint, minimal resources, and be cost effective, but still you want to be modern and aesthetic, and you want to use custom icons, textures, and so on. So whether you start from the low-end side and then make the high-end, or the vice versa, you want to market first your flagship, your high-end device or car, and then strip it down to a microcontroller or a more cost-effective design. Doesn't matter. You have, of course, there are some rules how these developments need to take place, but in the end, both sides, and in the middle you have the central one, both sides are nicely achievable and maintainable with our platform here. I give you another example. We spoke about localization as a part of the worldwide marketing. That is key. Whether it's a small variable device, so to achieve high volumes, it's important. Here's an example with an IMX RT500, where it's a small footprint, where we optimized and say 300 kilobyte RAM and 500 kilobyte flash in this design. Who's interested can find videos about that in the web. It's key that you can, for instance, outsource to professional translators which don't necessarily have programming knowledge. So this is one of the tools needed. Another one is the Qt Assistant for building and viewing online documentation, whether it's for internal use or external use or guided applications for the users. Doesn't matter. You need to manage the content in different languages, and you need also a tool for that. A nice example how collaboration works is this little application on an IMX7 Solo, which is a e-bike application. Just in short, the flat tire alert here on the right side of the picture seems like a very simple feature, but it finally requires hardware engineering, RF design, because you need to get the sensor data somehow into the little computer. You need some protocols probably, and UX design, visualization, and in the end also a language and maybe a unit of measurement like PSI or bar. This is something which needs to be incorporated, and if I look at it, I think my wife would rather appreciate if it would just show flat or not flat. Another example is the safety requirements, which you find a lot in automotive, but also in some industrial segments. So we have the safe renderer for those things as a tool, a part of available for different categories as well for MCUs or combination or with MPUs. But the important part here is how can we achieve a collaborative development in such a complex thing. And again, you can build the whole thing in a desktop, and then when you need to do your software build, you can decide later on at that point whether it needs to be an ASIL-D requirement, which components actually, which components of your UI need to be are safety critical and need to be in ASIL-D environment, and which of those are not critical and can run on a normal cluster UI with a different rendering. Now, just in short, quick controls is a very nice and important part. This enables you to make customized styling across your company, your products for the company brand. It's kind of a ready-made controls, which you then can also customize, and this definitely improves your work. Another one are the libraries and APIs available here. This is something which is appreciated highly, and yeah, shows the different ways how to develop and reuse code as much as possible. Coming back to the oven example, actually, we see that the trends is not only to have a more complex and more connected devices, but we also see that there is a lot user interactive requirements. So it's sometimes touchless and hands-free, which makes sense if you are in the kitchen. But also you want to have a guided tour, maybe if you have a cooking example, can apply for other things. So there is a more complex software to be done. And here you can also see the latest trend in designs. So this is in dark mode and adaptive brightness, and this ensures the maximized readability. This has been proven by several studies and seems to be an ideal mode to be able to read fast and get everything. And it's kind of a modern look as well. As another trend, you may, of course, everybody or most of the people would also like to incorporate 3D elements. and for product representations, whether it's a pizza or something else. Of course, that is more catchy. And some nice ones is glass morphism, which is a kind of multi-layered view and with floating objects and a blurred background, kind of modern for very specific use cases, maybe very applicable. And neomorphism, for instance, it's a plastic extruded look, and it's mimicking a real textures. Very interesting design style. And I would like to finish my presentation with my favorite dashboard in automotive. So there we close the loop. This is the new Echo in Daimler. And if you sit in that car and look at that dashboard, then you really feel that the future has just started, like it starts every day. Thank you very much, and I hope we have some time for some questions. Please download the white papers and look at the technical trainings. They are worth it. Thank you very much.